For 3.5 inverse relations, I first go through the concept. For any relation, it could be a function or it could be just a relation. For example, y equals x over 1 minus x. It is a function and a rational function we learned. And it is in a form that you can tell one, y is isolated, or you can see y is explicit. And then if you see the x is implicit, right? You can see it's not expressed as explicit like y. And then normally we just write a function notation as y equals fx. So the fx really means an expression in terms of x, right? If you consider the function is a machine, as I did this analogy before. So the box is just doing some operation. So if you drops a number, say x equals 2, so the 2 will come to all the brackets here. Okay, so x2 will come to here and here as well. So you can do the calculation 2 divided by 1 minus 2, you should get negative 2. So that's your product. So just like a machine. Okay, so that's for the original function, y equals x over 1 minus x. But if you isolating the x, okay, we can do it this way. You multiply 1 minus x on both sides. So 1 minus x come to here, and on the other side cancelled out. And then you expand this, you get y minus yx. Okay, so we need to combine the x. So I plus yx, so I cancel this and got yx over this side. And then just factor the x out on the right side. You got 1 plus y and multiply the x. On the left side, we only got a y left. And then you divide it by 1 minus y on both sides. And then you end up getting y divided by 1 plus y equals x. Of course, if you look at this, it doesn't really it doesn't really look like same as original one. So original one on the denominator is 1 minus x. Here is 1 plus y. Okay, now this is a form. X is isolated. X is expressed explicitly. Or you can write x equals y negative 1 y. So the negative 1 is just a way to express its kind of inverse relation in terms of the expression, right? So the expression, if you compare the fx and the f negative 1 y, is just kind of inverse relation because you isolated y here, and here you isolated x. So this kind of relation is called inverse relation. Okay, now if you check how the machine works, originally if you put x, you get a y, x equals 2, you get a negative y for the y, negative 2 for the y. And then if you do this, reverse the process, if you push the number in, normally a machine can't really reverse, but what if we assume it can be done this way? So we push the negative in from the output, and then if you do the calculation, you actually can get the 2 out, which works kind of the same way as the original one. It just reverses the order, right? Okay, so then these two relation, if you only compare the relation between x and y, it's no difference. Okay, the difference is just which one changed to a independent variable and which one becomes dependent. I just switch these two things. So x is independent, so you take as input, and y is output. Here you just reversed. You take y as input and then x is output. They got a basically same relation. X and y, they still got the same relation. But you can see this is actually gets reversed. So this is actually the f negative 1 relation. Okay, and then but if you look at this, if you try to put an x in here, okay, so you can produce the x equals 2 if you put a negative 2 in from here. But what if you try to put the x2 here in, and then if you go through this process, you go through the inverse process. So because basically the machine is different. If you compare this to this and this, they're two different machines, right? If you still put the x equals 2 to this machine, and then you can see you get y equals 2 over 3. So the machine is different. Basically f and f negative 1, they're inverse relation. So they're different kind of expression. If you look at it, the relation here is bracket over 1 plus bracket, while the original one is bracket over 1 minus. So obviously they're different. In other words, you can do this when you plug in the 2 into the original function, you get negative 2, and then if you plug in the inverse negative 2, you get a 2. So you can see these two things, they're still the same thing, right? Just as the graph demoed here. Okay. So finally, we can get this conclusion. Y and fx and x and y f negative 1 y. These two things, you just change which variable is isolated. So it doesn't really change the relation between x and y. So they're still considered equivalent. But if you compare y equals fx and y equals f negative 1x, now what you changed is, if you compare these two, you switch the x and y. Okay, if you switch and x, y, and because the f negative 1 is different from the original one. Okay, so if you compare to these two are different. These two are equivalent, but these two are different, right? If you compare y, same y, x, same x, but the f and the f negative 1, they're different expression. So these two, they're different, and they are called inverse functions. So you can see they are inverse to each other. So this one is the inverse of this, or vice versa. So this one is the inverse of this. Okay, so that's the concept. Basically, if you switch x and y, it becomes inverse. Okay. Okay, now let's look at this a different way to say the same thing. If there's a point AB on the original function, right, and then there is a corresponding point BA on the y equals negative 1x, right?